So good morning to all the construction professionals. Good morning, Dr.A Sudhakar, for sparing your time to interact with us. So today he would be talking about usage of alternate aggregates. So before that, let me just give a brief overview of the organization. All of you know about Ramco Cements, flagship company of the Ramco Group. Ramco Group, as all of you know, started from the 1930s. Cement was we entered into the cement in the year 1961, and since then we have been introducing various kinds of technologies at various stages of manufacturing cement. And we have, as of now, we have 12 brands of cement, spanning various types of cement: ordinary Portland cement, PPC, PSC, SRC, and Ramco Superfast for precast application. So based on the concrete requirements, we have the cement. So it is very important that we understand the concrete requirement and then specify the type of cement. So we follow that, as all of you know, we have been emphasizing on the right product for right application, rather than saying that you can use OPC for all applications, PPC for all applications, PSC for all applications. We always emphasize that you must understand the requirement of concrete and then specify the type of cement. And presently our capacity is 16.45 million tons per annum, which is expected to be 20 million ton per annum, with our plant coming up at Kurnool, as well as our grinding unit in Odisha. And most of the other expansion is through. So we are expected to touch 20 million tons per annum. Apart from cement, we are also into ready-mix concrete. We have a RMC plant at Chennai, and we have a dry mortar product which is established in collaboration with MTech Germany. And dry mortar product, as all of you know, is very useful for non-structural applications, especially if you look at plastering or say, for example, super fine for which is our cement-based putty. And we also have tile grout, and we also operate one of the largest wind farms in the country, because from the sustainability perspective, that is very important. And this is just an overview of the various types of cement that we manufacture. So you could see that within ordinary Portland cement, as per IS 269, because as all of you would be aware, now there is no longer separate code for 4353. Everything is combined, and it is IS 269. And we have also introduced a new customized cement for those applications where you need higher slump retention. That is why you have the Ramco Infra 53 grade. Because when we were doing trials with chemical admixtures, we found that we could help in further ensuring that the slump retention is higher, and especially in cities like Bangalore, when concrete is being transported over longer distance. And all of us would be aware that now the construction sector is also using precast applications, and for that we thought, why not have a specific cement for precast applications. So we have introduced Ramco Superfast, which gives you a higher rate of gain of strength, because as all of us know, that precast application requires faster removal of mold, minimum breakages, edge breakage should be minimum, and then of course economy is also being looked into in terms of number of blocks per bag, which all of us, which all the precast units want to be in higher numbers. So that is what Ramco Superfast helps in achieving. And then we have the PPC cement, the Super Grade, the Supercrete, the Super Fine, and Karthik Super Plus. And Supercrete is a cement which has been customized for all concreting applications, with the advantage of having a high rate of gain of strength and low heat of hydration. And then we have the Portland slag cement, Ramco Super Steel and Ramco Samudra, and we have the sulfate resisting cement, Ramco Super Post. And some of our major customers, we have good association with major infrastructure customers like ITD Cementation, Larsen & Toubro, and various other projects in the eastern part of the country, and with various other institutions like metro projects. Our brand is approved in almost all the metro projects, whether it be Chennai Metro, Bangalore Metro, Kolkata Metro. So our brand is approved there. And we also have, when we interact with various projects and construction professionals, what we have found out is that there are a number of chemical admixtures that is available in the market. And we ensure that trials are being done at our research center, the Ramco Research and Development Center, which is also an NABL accredited lab now, wherein you can get various testing done. We have our various raw materials of cement that is being analyzed using the state-of-the-art evaluation mechanism. You know, we have the X-ray diffractometer, and we have the mercury intrusion porosimeter, and various instruments to look at the various aspects of raw materials as well as cement and concrete. Ranging from, say, for example, heat of hydration measuring, durability measuring equipment are there. Because what is important is that we need to ensure that the durability of concrete is there. So that is very important, and we thought, we should emphasize on that. Now, Today we have our speaker. Let me just give a brief introduction of Dr.A Sudhakar, who is presently the Secretary of the Indian Concrete Institute at Coimbatore Center. He is a practicing structural consultant offering structural, architectural and project management consultancy services inside and outside India through his consultancy firm's Dimensions, and formerly he served as the regional head technical services in various cement companies, and he's also serving as a mentor, advisor and expert committee member for various universities, engineering colleges and polytechnics. So that is very important because he's having a good blend of both site as well as academics, and also is involved in educational programs. He co-owns TNBP, Green Building Center at Coimbatore, which produces many eco-friendly building materials. He is the Director, Academic and Skill Development for the upcoming Sir C.V. Raman Polytechnic College at Coimbatore. He has served as the Secretary for the Association of Consulting Civil Engineers, India Coimbatore Center, and is an active member of other engineering bodies such as BAI, CE, BACA, ACI, ISHRAE, AC, etc. So, with those few words, let me again welcome Dr. Sudhakar, who would be talking to us about a very important topic today, because as all of us know, aggregates constitute the major component of concrete, and how far we have been paying attention to that. So at the end of today's webinar, I am sure that all of us would be having a lot of takeaways. So I do not want to take much of the time, and let me once again invite the speaker. Over to you, Dr. Sudhakar, for your presentation. Thank you so much.
Thank you, sir. First of all, I would like to express my sincere thanks to Ramco Cements for having organized such a platform to interact with engineers. Honestly, this was one brand which I have always admired for its consistency in quality. I've been involved in benchmarking so many brands of cement in the market. So by data, I know you are very consistent. So I thank you for selecting me to interact with the engineering fraternity, sir. And thank you for selecting this topic, first of all, which is very close to my heart. That too with the recently growing awareness on sustainability, protecting of rivers, and there are so many environmental related issues which are talked about nowadays. So with this preamble, I would like to go to the presentation straight away. Hope I am visible, sir. Presentation is visible to you. Can someone confirm? Yeah.
Yeah, we are able to see now. We are able to see.
So on the outset, a very important topic, alternate aggregates. But I know you would appreciate the fact that I cannot make you an expert on alternate aggregates in an hour's time. So what I would be doing is I would be giving you a preface for using alternate aggregates, which means it is only a foreword. I will give you a lot of leads to ponder upon, to study and experiment with alternate aggregates in labs as well as in your sites. On the outset, I would like to emphasize on the need for thinking about alternate aggregates because I believe alternate aggregates should not be used just because you don't get the conventional aggregates, or conventional aggregates are becoming costlier and dearer. See, you should see this gentleman in the picture in the screen for the benefit of the other state participants. He is Thiruvalluvar, the great poet who has given the Ulaga Podumarai, the world literature, Thirukural. And hailing from his part of the country, it is our duty to be more sustainable. So this is the key takeaway from today's topic. The use of alternate aggregate should be more towards reducing the carbon footprint of our construction rather than using it for technology's sake or economy's sake. Of course, those are all benefits which we will of course achieve. But I think according to a practicing civil engineer, his first responsibility is to reduce the carbon footprint, and that is why alternate aggregates take a driver's seat today, at least in the today's topic. And this is one of his famous Tirukural. Excuse me for the blurred graphics. It is Katka Kasadara Katpavai Katrapi Nitka Adarkitaga, which means while learning, you'll have to learn it without a speck of a dirt, or you should learn it thoroughly. And more important than learning is you should stand by what you have learned. And this is where we as civil engineers sometimes fail in implementing sustainability. We all study about carbon footprint. We all study about being environmentally responsible. We all know usage of resources scrupulously would lead to more emission of greenhouse gases. Therefore, this will happen, that will happen. All this is known, but are we really standing by what we have studied is very important. That is why the last three words in this Tirukural is very important. Nitka Adarkitaga, which means you'll have to stand by what you have learned. And I think it is the order of the day that you'll have to stand by what you're going to learn in the next 1 hour and start promoting the use of alternate aggregates. Now, this also is connected to Tamil literature. I will quickly go through this. Tamil literature has always classified the type of lands where people are living into 5 different categories. One is Kurunchi, which denotes hilly areas or hill-related areas. Kurunchi. Mullai is forest-related area. Marudam is agriculture-related area, especially in the plains. Neithal is sea coast or something related to the oceanic culture, which is Neithal, and then it is Palai, it is the desert area. Now, what is peculiar about this land classification is you can classify lands, the livable lands or the living ecosystem into built environment, or in modern day context, into 5 different categories: Kurunji, Mullai, Neithal, Palai, etc. These 5 categories. Each of these categories will have a definite form of a lifestyle. They will have a definite form of a fashion. They will have a definite form of a worship. They'll have a definite form of food habit, etc., etc. Which means each of these landforms would follow a particular kind of a lifestyle. So those days landforms were classified into 5, but today we are completely in a different kind of a landform. We are living in a completely different ambience today, built environment today. So what should be our lifestyle for this kind of a landform? The answer is sustainability. Though the other landforms had their own way of living, their fashion, their culture, their methods of worship, etc., etc. Today, sustainability is, I believe, sustainability is the only religion which will sustain in the future, because now COVID has taught us a lot of lessons. All our gods and goddesses have been amalgamated into one supreme spirit. We are only praying to one supreme spirit to save us all from this pandemic. So similarly, there is another sort of a pandemic situation, which is global warming, which is going to affect everybody, not only humans. It is going to affect the whole ecosystem of the earth. So the only religion which we have to follow in the future would be sustainability, and this is where thinking about alternate aggregates becomes very vital. Now, let us have a brief peep into where did we start using aggregates, or why do we need aggregates? See, actually, we need aggregates for construction. That's a very simple answer. But where did this construction begin from? We actually started construction not from man-made constructions. We started construction from natural constructions, where humankind was residing in caves, which was construction by nature itself. We did not build caves, at least. But the first forms of human constructions were huge. The civilized constructions, like what you see here, the Brihadishwara temple, the corridors of the Rameshwaram temple, these are all so huge. But if you look at these through an engineer's perspective, you would be really amazed in understanding how they could handle such large quantities of stones. Most of them were monolithic, for at least the pillars were monolithic. The ceiling slabs, what they used, what you see in this corridor, it's a stone slab. Probably it's around 8 meters to 10 meters wide at least. They were able to handle such large uh, loads, and they were able to dress stones. Availability of stones were there. Therefore, the first forms of civilized constructions were all huge, and they mostly used stones. Then the limitation on handling such large loads came into picture. So we started using smaller stones. If you look at the picture here, we started using stones only, but at a smaller load level, which means we have reduced. We also started the usage of bricks, which were imitations of stones, but at a much smaller level. So from large stones, we moved to small stones. From small stones, we moved to lighter small stones, which is the bricks and the small clay tiles. That is the predominant kind of material used in the palaces of Karaikudi, South India, anywhere in India for that matter. So we came to smaller stones. Even bricks and lightweight bricks were used for construction of floors. The famous Madras terraced flooring, what you see here. We started using stones for, or the bricks as stones for weatherproofing, etc., etc. Even temple monuments were built with bricks. Now we have moved to still smaller stones, namely the coarse aggregates. Now, in one perspective, I feel the capacity of a single human being to carry large weight has gone down due to some reason, some evolutionary reason. So we will have to delve deep into Darwin's theory to understand that. But as such, our one side we have been improving in technology, the other side we have been traveling towards convenience of using stones, and thereby we started developing alternates for stones, and we have ended up in something called concrete, which is nothing but an imitation of stone itself. Only thing is we use smaller size of stones, we use various other ingredients, make it very workable, moldable, and we cast them into the different shapes what we need. And once they set and harden, they again imitate stones. So the funda is to imitate a stone. So we started using concrete. So what do we have in concrete? Any civil engineer's answer would be concrete is a mixture of coarse aggregate, fine aggregate, with a binder, with water and some chemical admixtures, blah, blah, blah. There is a theoretical definition to it. But each of these ingredients have got a definite role to play in the concrete as a matrix itself. So what is the role? What is the role of each ingredient? That has to be understood properly. Okay. Now looking at concrete as a replacement for the stones, what is our requirement out of concrete? It is definitely the strength, because that determines the engineering parameter in which you can design these structures, design these imitated stones, the concrete. Of course, the workability, because workability will define the ease in which you can cast them into the required shape and size. So the ease of casting is called workability. So we need strength, we need workability, and we also need durability, because we need to have a very practical and affordable lifespan for the structures what we design, for the concrete structures what we design. Now, if you look at concrete as a matrix, there are a lot of factors which influence the performance of concrete as a structure. The major headings are materials, the concrete mix itself as the mix proportions of concrete, the method of construction you do, and the design you do for the structure, not the concrete mix design. I'm talking about the design. If you look at the materials, aggregates are there, the type of aggregates, the grading of aggregates. We'll be dwelling about this in detail in a little while from now. So the materials, namely aggregate, cement, water, and admixture, have a key role in determining the quality of concrete and therefore in determining the performance of the concrete structure. Coming to concrete, the appropriateness of the mixes used, the quality control exercised during the preparation of concrete itself, the quality control exercised during the transition phase of the concrete, the maintenance phase of the concrete, all these will play a critical role in the performance of the concrete structure as such. Then construction, yeah, this list is longer, as you can see from the graphics itself. See, the kind of element design you make, for example, as a structural engineer, I would say designing the concrete skeleton, if you say, for a framed structure. So designing that under a band of a lower stress band would result in better performance and also higher durability. Meaning, in simple words, it means like you don't have to stress your concrete members to a very maximum limit. Under stressed members are naturally more durable and they perform better. By saying this, I would also caution you not to go for over-designed structures which will kill the economy. So you will have to play optimum between the stress levels and also the economy you will achieve. So the element design, the building practice, namely the quality of formwork you will do, the kind of tolerances you will have in the levels of formworks, the kind of tolerances you will allow in the slump while placing the concrete, the kind of reinforcement, the quality of reinforcement, the pattern of distribution of reinforcement, the quality of compaction you would achieve, the kind of curing you will do, the duration of curing, the kind of quality of water you will use for curing. All these play a very, very significant role in the performance of your concrete structure. After all, the end customer, the end user is worried about the structure and not about the concrete or the steel or the water, what you have used. He is worried about his final product, not about each and every ingredient he has used in the construction. And design, the kind of designs you use. I will quote only one small example for design, how design would affect the performance of a structure. If you have observed, the structures of the 60s era had more of curved surfaces. People were using, it was architecturally, it was hailed as a good design if one would use a circular column, curved edges, not the sharp edges and all. If you happen to observe any of these structures of this era, which is still now surviving in many places, you would see these structures are crack free. They are more resilient towards weather. They are durable. That is because of the effect of the engineering design itself. Because circular structures will not have stress concentrations, and therefore lower stress. If you stress it lower, then your durability goes up because the possibility of cracks come down, micro cracking comes down. So each and every aspect of your design also has an impact of the impact on the performance of your concrete itself. So if you look at this whole matrix, if you look at all the factors listed here in this slide, you would now realize that aggregates is just one small part. So just because changing an aggregate would not be detrimental to the performance of your concrete structure as such. So I think this slide is more important to understand, because you should come out of the fear of changing from your conventional aggregate systems. Nothing is going to happen, because the performance of the structure is not only dependent on your aggregate, but it is dependent on so many factors as listed here. So aggregate is only one part of it. It doesn't mean that you can use anything as aggregates. I've seen a lot of researches happening. Whatever is classified as waste material, that will be pulverized or resized into an aggregate form. It will be replacing either the coarse aggregate or fine aggregate in various percentages. some compressive strength graph is drawn, and we come to a conclusion. You can replace this up to 20%, 30%, 50%, etc. No, that is not the motto here. You'll have to understand that usage of alternate aggregate is possible, but not scrupulously. And just by changing aggregates, it is not uh, uh, interpreted that your performance of the concrete structure will go for a toss. Now let us understand the ingredients one by one. The most predominant ingredient, the talk of the town today, is about the fine aggregate, especially coarse aggregate. Though we have not felt the pinch now, sooner or later we will also be facing a dearth of availability of the coarse aggregate also. So it is important for us to understand the replacement alternatives for coarse aggregate also. But today we will more about fine aggregate, because the river bed protection is the need of the hour. Governments are preventing mining of fine aggregates from river beds, and therefore it is very important to understand the usage of alternates for fine aggregates. So for a few minutes from now, we will dwell upon alternates for fine aggregates, for which you will have to understand the role of fine aggregate in concrete. Now, what you see here is a traditional sweet or a snack of Tamil Nadu. It is called the Pottukadalai Urundai. I don't know its translation in other languages, which is basically made out of a gram and jaggery, which I would correlate, or I will draw an analogy to coarse aggregate and binders. Uh, See, if you make to bite this and eat, it's a task. So it will be a pre-dental checkup if you try to eat this. If you can easily bite this and eat, then it means your dental system is quite okay. If you are not able to bite it, you have pain, and it is very difficult for you to bite, then probably it's time for you to visit a dentist. So it will be that hard. Now, what do we learn from this is, if a concrete, as we just saw, the primary requirement of concrete is durable, I mean, strength. So if concrete becomes as strong as this, and if its macro structure can also be compared to this, then are we achieving the purpose? No, because this has got a lot of porosity. If you try to pour a spoon of ghee or water or any liquid on top of it, you can understand that it will start oozing through and it will percolate out. So which means it has got voids. If a concrete is prepared in such a phenomena, of course, it might be strong, but it is not void free. So it cannot be used for roofs. It will not protect you from the rain. If you are using reinforcement inside, it will not protect the reinforcement from moisture as well. So to prevent ingress of liquid inside this, you have another snack, which is also produced from the same ingredients, but it is prepared from the flour of that gram. It is called ma laddu. So that particular gram has been grinded into a finer form, which I would like to compare it with fine aggregate. Same jaggery is used and made into form of a laddu. Now, what you feel, if you pour a spoon of ghee or any oil on top of it, it doesn't percolate inside. So it is dense. So it will very well protect your reinforcement system if you can prepare a concrete like this. But what you will observe is you will not get the strength, because if you use the same amount of jaggery, the strength development, the kind of stiffness which develops inside this snack is reduced. Which means if you are using finer material, you will have to use more jaggery. In concrete terms, if you are using finer material, you will have to use more cement, which will again kill your economy. Now, this is good in terms of one functionality of not allowing water to pass through, but it doesn't satisfy your strength without sacrificing your economy. Now, we had found out a newly improvised snack, which is a combination of 1 plus 2, which has got the coarse whole gram as such, and the flour of the powdered form of the dal, and also you have jaggery. Now this system satisfies both. It offers you the rigidness or the strength of the first one, it also serves as an impermeable system where you cannot percolate any liquid through this. And if you can relate this to concrete, this would be the perfect analogy. So the coarse aggregate form the primary filler of the concrete system. They can themselves give strength provided you have enough binders in them. And if it is designed as such, I know you are all aware of no fines concrete used for pavements which needs to percolate water. So no fines concrete is there. So but that cannot be used as a structural concrete. So for structural concrete, you need the impermeability also as a function. Therefore, you are adding something finer also, which is fine aggregate, and the jaggery does the binding part, wherein in concrete you will use cement as the binder. Now, in this, you would understand that the fine material is basically doing the job of filling the voids of the coarse material. That is what is the primary function of a fine aggregate in concrete also. It acts only as a secondary filler, which means it fills the gap of the primary filler. So the fine aggregate role is basically to do the secondary filling. That is the moral of this story. Now come to the binder. The understanding the behavior of binder is very vital for us to understand whether you can use a particular form of aggregate replacement or not. To understand cement, you need to understand cement through the following properties. Slump loss, which the cement will create in a system. I will not explain each one of this in detail for the paucity of time. I will have to close by 12. So slump loss, bleeding characteristics, the volume change in concrete, water demand vis-a-vis the ambient temperature, the air entrainment stability in stability of the concrete system, the rate of strength development, the permeability of the concrete, the compatibility of the cement and the admixtures used in case you want to alter its rheologies. If you understand cement through these perspectives, then you will understand aggregates as well, because it is after all the cement which has to interact with all the aggregates what you are going to use, whether the conventional or the alternate aggregates. So you will have to have a deeper insight into cement, particularly through the following rheologies. Because if you understand cement as cement itself, maybe through its chemical characters, the fineness of the cement, etc., it is good. But for you to adopt any new system of aggregates, you need to understand cement through these perspectives. Probably you can request Ramco Cements to arrange for one more webinar for understanding cement through the properties of concrete rheology, not through cement performance. It has got two implications. One is the physical properties of cement, which can affect the rheology or performance of concrete. Physical, by meaning physical properties, I'm talking about the particle size distribution, setting time, consistency of cement, etc. There is also a the chemistry of cement itself, which is also very important to know, which is like how the Box compounds are reacting, what would be its implication in the isothermal conditions of the concrete, which compound will react when, what is the sequence of reaction, when would the ettringites be formed. All these are very vital for us to take a decision whether we can introduce a particular form of aggregate as a replacement for the conventional aggregate, because each aggregate has its own physical nature, chemical nature also. So we need to know where we can fit in the chemical nature of our proposed aggregate into the system, with the view of the cement being used, because as of now we don't have an alternate for cement as such, at least on a commercial sense, on a practical sense in a construction site, wherein replacement for aggregates has already reached a practical level at the site level also, at the project level also. So it is important for us to understand the chemical reaction of cement, for which I've just given this graph as a representation, which talks about the isothermal conditions and role of each of the Box compound in the hydration of the cement as such. Coming to aggregates. If you have to theoretically classify aggregates, you can classify them into three types, or rather two: the primary aggregates and the alternate aggregates. But on an academic level, people have uh, uh, people of academics have segregated this into three categories. One is the primary, the other one is alternative, the other one is manufactured. On a practical sense, I would treat both alternative aggregate and manufactured aggregate into one silo. These are all alternates for the conventional or the primary aggregates. These alternative aggregates is further classified into recycled aggregates and secondary aggregates. Recycled aggregates are basically, the name itself suggests, it is primarily the construction demolition waste, which is again brought into use. So maybe a concrete again pulverized and segregated into coarse aggregate and fine aggregate will come into construction demolition waste. We would also be looking into what the code book has to say about these alternate aggregates. I'll be sharing some of the snapshots from the code books also. But basically, these are all recycled aggregates, either in the aggregate form itself, that is seed construction demolition waste, or it could be a byproduct from other industries. For example, bottom ash, copper slags, steel slags, etc., etc. These are all byproducts from other industries, which can be used as an alternative for the conventional aggregates. So primarily, there is a primary aggregate which are from natural sources, recycled aggregates which are the primary aggregates itself, which are again recycled. After the first usage, it again comes to the secondary usage. You have the manufactured sand, which is only a form change from the primary aggregates, and then you have alternate aggregates, which are the industrial byproducts, which are replacing the primary aggregates itself. If you look at concrete as a matrix, in terms of weight, roughly 3/4 of it, 75% of it is constituting to the aggregates mass. In terms of volume, it is 2/3. You can see in both the pie charts there is only one major difference, the presence of air and entrapped air. In terms of volume, it is quantified, wherein if you take as mass, you cannot quantify that, because for a concrete system the weight of air is treated as zero in terms of mass. So the moral of this chart is we should acknowledge that the majority of concrete, the major part of concrete is only aggregates, and cement, though it is very vital in terms of both by mass, also by volume, the quantity is very small, though its role is very significant. Okay. Now, what are the requirements of concrete aggregate? Any concrete technology textbook would be able to tell you these requirements. It should be sound, which means it should not have a volume expansion or a contraction in terms of variation of temperature. It should be very sound. It should be clean. It should not have dirt or other impurities. It should not have a potential of alkali aggregate reaction. It should not react with the alkalis from the binder, namely cement. Its shape is very important. It should not be flaky or elongated. Yes, it is in terms of the workability point of view, but there are many situations where shape does matter in terms of the finish expected, especially in terms of exposed concrete surfaces and all. And the shape and size of the aggregates matter a lot, more than the engineering qualities of the aggregate itself. So they, as we just saw, they form up to 80% of the volume of concrete. They are ideally assumed as inert fillers, as long as you want to consider them to be very inert and non-participating in the system. But modern day research is finding a lot of information that aggregates can also participate in the hydration and result in different performance of the concrete system as well. So it is not always imperative that the aggregates has to be considered as inert only. The size of aggregates does matter, as we were just discussing. If the size of aggregates go smaller, then the requirement of the binder becomes larger. As you would appreciate, smaller aggregate for the same mass. If you have two different sizes, then the finer system would have more surface area, which means it needs more binder to coat itself. So as a result, you will require more cementitious content in your concrete system. So this graph is a simple depiction of it. Don't take the values, but look at the pattern of the graph. If your nominal aggregate size is increasing, your the requirement of your cement adequacy will come down. So if you have to stick to aggregate classification as far as concrete technology is concerned only, then whatever is above 4.75 mm, you classify them as coarse aggregate or gravel, and whatever is between 75 microns and 4.75 mm, you classify them as sand. Even though very purely you cannot take away minus 75 micron sizes from sand, but generally if you look at a particle just below 75 microns and further down, you classify them as clay or silt. It doesn't mean they will not be present in the sand system. They will be to very negligible extent. So sand is basically between 75 microns and 4.75 mm. The important characters of any aggregate would be its shape, the texture, shape in terms of achieving workability, achieving the compaction required, achieving the minimum void content. All those things are determined by the shape of the aggregate and also the size of the aggregates. The texture will play a key role in the inter particulate friction, and therefore also will affect the workability of the concrete system. The grading, the different sizes available. We will talk about grading through an example now. The grading, the color, strength, the water absorption, surface. These are all very theoretical stuff which any checklist on aggregates would be able to tell you. Of course, the last one, resistance to freezing and thawing, is not a very particular, I mean, a very prominent feature which is looked into Indian conditions. But in our projects, what we are doing in European countries, this is a very important point. Talking about the shape of aggregates, the most I'm talking about any aggregate which includes alternate aggregates also. Now we are talking very generic terms as in the form of aggregates, and slowly we will move into alternate aggregates. Now this is applicable for any aggregate, primary or alternate. So the desirable shapes are mostly rounded, irregular, and angular. Rounded, irregular are very difficult to manufacture. Angular is it is easily manufacturable through the modern VSI systems of MSAN manufacturing. What should not be there is the flaky or the elongated aggregates, as you would appreciate the fact that this will create a lot of interparticle friction and therefore will not allow the concrete to flow. So if you have to achieve workability, you will have to achieve them through either by increased fine aggregate content, which means you will have to add more cement, you will kill economy, or through increased water cement ratio, which will bring down the strength of the concrete system, or through increased usage of admixtures, which will again not make your cost effectiveness so viable. So on a selection of aggregate level, you should be very particular about the shape and the size. Aggregate grading affects the following properties of concrete. It will also influence the water requirements. It will influence the workability, pumpability, economy, which is a very common sense thing. Anybody who has touched concrete would be able to appreciate all these things. A bad shape of aggregate means a bad economy of the concrete itself. This is a graph which we would have done umpteen number of times when we were a student. Sometimes those who are in the labs of construction companies would do it. I was just chatting with Anil sir about this particular aspect. A lot of us don't understand the importance of these grading curves. In fact, we don't understand the meanings what these grading curves are telling us. There is a reason for us to plot these in a semi-log sheet itself rather than a normal graph sheet. Try plotting a particle size distribution in a normal graph sheet. Probably you would require a graph sheet as big as a 10 by 10 wall. So to make it comprehensible, to make it practically usable, we are using a semi-log sheet. So you should understand the implication of these shapes on the particle size analysis. Maybe be it the fine aggregate, coarse aggregate, or all in aggregate. I've been trying to push this as a very important point in the concrete technology syllabus in various universities. The sieve analysis of all in aggregate, meaning the coarse aggregate plus fine aggregate put together, is giving a lot of meaning to concrete mix design rather than looking at the particle size distribution in isolation. So this is what it is. See, in this, I will not delve into the mathematics part of it, but what does this show? The shape A shows that the aggregate is too coarse. Shape C means it is too fine. Shape B is optimum. So we need to understand this language of graphs before we set in or before we start understanding mixed design of concrete. So I would request, especially if there are students watching this lecture, please delve more into these graphs and try to understand what they are trying to convey us. We were just talking about grading. This is a nice and a recommended grading system where you can see this is actually a cut section which is polished. It is not a mosaic or anything. It's a regular concrete element which has been cut and polished. You can see the presence of particles of all sizes, especially the coarse aggregate. This means it's a more practical grading. This will give you a very dense concrete microstructure. Wherein this is a very bad grading, I would say. There are predominantly only 3-4 sizes which are present here. There is a lot of void in the system. This is not a depiction of a good quality of concrete which any designer or a civil engineer would try to achieve. So this is what is meant by grading. You will have to understand a lot of graphs, the all in aggregate graphs, to achieve that. The moisture content of the aggregate, the behavior of the aggregate versus vis-a-vis moisture, because all our mixed designs are done based on this saturated surface dry condition. So while choosing alternate aggregates, we should be convinced, or we should have a note, we should have a cognizance of whether our aggregate will be able to achieve this condition during the mix. If not, what will be the condition of the aggregates when we use it practically, and therefore what should be the kind of alterations you should do to the mix design itself. It is not that you create a mix design for the primary aggregates and you just replace 10%, 20%, 30% of that with the alternate aggregates and then do the experimentation. No, if you are replacing it with 10% of alternate aggregates, you will have to see what are its implications in terms of moisture absorptions, etc., etc. Alter the mix design accordingly and then do the casting. The moisture content test, nowadays it is replaced by infrared moisture meters. The checking of impurities and fines in aggregates is very important, and it is very important in terms of alternate aggregates, because the presence of fines or even chemicals like cellulose, sugar, or acid, etc., will do a lot of interaction. Will do a lot of hindrance to the binder performance itself. Therefore, you'll have to study all these before you choose a alternate aggregate system. So we will quickly go into the alternate system. Now, if I have decided to do an alternate aggregate system, what should I do? I cannot just like that take an alternate system, replace them with replace them for the primary system and start using the concrete. Now, I should authenticate. I should have a at least I should be self-satisfied and certified to use that alternate system. So I started searching who is the authority to permit me or not to permit me to use a alternate system, where to refer, how to approach this whole process. So I started browsing through the basic book, which is IS 456, called the uh, Bible of the Civil Engineer, or at least the Indian Civil Engineer. So when I started browsing this, I found that under the aggregates section, clause 5.3, it says aggregate shall comply with the requirements of IS 383. As far as possible, preference shall be given to natural aggregate. It's as far as possible. I think in the next edition of IS 456, they will change this. We should in fact be telling as far as possible, we should be giving importance to non-natural aggregates. Excuse me for a second. I am just running out of power here. I'm just trying to. Yeah. So IS 383 is the reference IS 456. So I switched over to IS 383. This is the old version, and now you have a 2016 version. So what IS 383 says, now you have the 2016 version, 2016 version, which is a code book for coarse and fine aggregate for concrete specifications. Earlier it was specification for coarse and fine aggregates from natural sources only. Now that word natural sources has been removed. Now it is only for concrete, which says in the foreword, it says the important points only I am sharing now. It says you can use aggregates from any of the grading zones. Give me a minute. We'll have power, but let's try to fix it there. Take it back. So you can use any of the aggregates from zone 1 to zone 4. But they say once, if you are using zone 4, then you'll have to be satisfied with yourself by conducting a number of tests. Meaning it doesn't bar you from using aggregates from any zone, which means many of the practicing engineers had a doubt. Whenever I interact with the practicing engineers group, they say, according to me, I am supposed to use only zone 2 sand. I will not use any other zone called sand. No, the foreword itself says you can use any sand, any sand from any zone, falling into any zone of classification. Only thing is, you'll have to make the mix design accordingly. So lesson number 1. Further, in IS 383 only, it has been mentioned, I've just highlighted that you can also use aggregates from sources other than natural sources. Now it is legally permitted. Your code book permits that. It also permits use of mixed sand. It is not necessary that if you are talking about an alternate system, you will have to use the alternate system completely. You can mix your primary as well as alternate system. You can mix aggregates from 2 different sources into the same concrete. So that is now legally being permitted. Now, again, what does it speak about fine aggregate? It speaks about natural sand. It speaks about crushed stone sand, popularly known as the M sand in today's parlance. Now there is one more sand called P sand. Instead of M sand, we are talking about P sand also, which is a more refined form of M sand used only for plastering. So you can use natural sand, you can use crushed stone sand, you can also use crushed gravel sand. Okay. Now it also permits utilization of iron slag, steel slag, copper slag. Now this is interesting. A lot of people are thinking iron slag and steel slag are same. No, they have the process is different. The chemical nature is also different. So you'll have to study them further in detail. It is a brief about all these manufacturing process and the usage of these alternates is uh, given in the annexure of IS 383 itself. So you can use iron slag, steel slag, copper slag, bottom ash from thermal power plants. Of course, fly ash is used by the cement industry, concrete industry, fly ash brick manufacturing industry. You can use bottom ash in form of aggregates. You can use recycled concrete aggregates. It is RCA, recycled concrete aggregates and recycled aggregates. These are slightly different. Recycled aggregates can also be bricks, recycled bricks, wherein recycled concrete aggregates pertains to concrete alone. The code books permits us to use any of these as an alternate. I was talking to you about the annexure. This is annexure A of IS 383, which talks about granulated iron slag aggregate. This is air-cooled iron slag aggregate used as a coarse aggregate, mind you. The one to the bottom right is the steel slag aggregate. This is copper slag aggregate used also as fine aggregate. Nowadays, you also have a coarse aggregate version of it. Demolition waste used as a construction demolition waste, CDW as it is properly called. So this as an aggregate. Recycled aggregate as an aggregate. Recycled aggregate, I told you, it can contain anything other than concrete also. It could be tiles also. It could be pulverized tiles also, which can be used as recycled aggregates. I visited a plant in New Delhi where they do a wonderful work about recycling these construction demolition waste. So if you can get leads to it, I think it will give you more insights into quality control of construction demolition waste. And now this is a very common question amongst practicing builders and engineers. Uh, we are all actually sometimes confused or sometimes we are cheated by the suppliers by these following parlance: M-sand, quarry dust, few documents measure indicate to them as CR, crushed rock fines. All these the same or all these different. Though the source, the primary geological source is the same, but M-sand and quarry dust is not the same. Their particle size distribution is not the same. Their participation in the rheology of the fresh concrete is not the same. So you will have to use them very judicially by altering your mix design. You cannot consider anything which is gray and powdery as M-sand. A lot of people are even cheated. So please do adopt site testing practices for M-sand usage at least. And you can develop your own testing manuals for site in case you are using other aggregates. See, this is again an excerpt from the IS 383 only. It gives a special mention in the last few lines. A crusher dust or quarry dust produced from the fine screening of quarry crushing cannot be called as crushed sand. It may not be generally in conformity to the requirement of crushed sand as per the standard, and it is not expected to perform as efficiently as properly as crushed sand unless it is processed to meet the requirement of this standard, which means it does not prevent you from using quarry dust as a fine aggregate, but you will have to process it or modify your mix design accordingly in order to use it as a fine aggregate. Otherwise, you will have to use only M-sand. These are the other terminologies given in IS 383. Apart from natural sand, you are using crushed sand, crushed stone. Under crushed sand, you have crushed stone sand and you have crushed gravel sand. You can have rocks being crushed or you can have gravel being crushed also. You can also have mixed sand, which is a combination between natural sand and M-sand or any other source of sand. You have manufactured fine aggregate. This is very important. Table number 1 of 383 also restricts you to the extent to which you can replace the natural sand. I find a lot of very high level researchers or the PG level researchers also happening in trying to attempt something like 100% replacement and all, wherein you have this stipulation laid by the code book that if you are using iron slag as an aggregate, in plain concrete you can only replace 50%, and in reinforced concrete you can replace only up to 25%. By ignoring this, if you go to 40%, 50%, maybe you will get your graph, maybe you will get your strength, but it will have long-term implications, because this has been prepared by properly studying the chemical nature, the interference of the chemical nature with the binder, the long-term effects, the effects of weathering, the effects of pollution, all those things was taken into consideration, and therefore this recommendation is given. So it is very important for us to take a note of this. If you are using it in plain concrete, it is a little bit liberal. Lean concrete, it is almost liberal, less than M50 grade. So for PCC and all, if you have to use, you can use even 100%, because they are only used for as temporary beddings, etc. They don't structurally participate. But when you are using structurally participating, or if the plain concrete itself is an integral part of the building system, for example, a flooring system, then you will have to adhere to the following limitations. For each kind of aggregates, they have given an upper limit for the replacement level. Please take a note of it. It is table number 1 of IS 383. Presence of deleterious materials. Yes, it is a very important test. Civil engineers should be knowing how to perform this test. I have seen a number of labs, or at least institutional labs, referring it to the chemistry department. They do a very compartmentalized testing without knowing the application part of it. So it is engineers are being trained in the deleterious materials test for aggregates. This is the table of IS 383. Of course, it is not different in 2016 version also, which gives you the limitation or the upper limit of presence of deleterious material. This is the table from IS 383 2016 version, again for deleterious material. Alkali aggregate reaction, I told you, you will have to take a note of the chemical content of the alternate aggregate to be used, and you will have to be ensured that it doesn't have a potential of alkali aggregate reaction, especially with the alkalis produced by the cement matrix. So these are the codal provisions. You go through IS 383. It is all very simple and very obviously given in the stipulations. Now, what I'm trying to highlight here is, don't be afraid in using an alternate aggregate as long as you are within the limits as specified by IS 383. What is very important is the grading. Next is the moisture absorption capacities of these aggregates. Then the chemical nature. If you are trying anything beyond and what is mentioned in the IS 383, then you will have to study the chemical nature in detail, especially in terms of presence of deleterious material and also the potential of alkali aggregate reaction. But what I don't want you to be afraid of is the zoning, particle size distribution of manufactured sands or alternate sands, because if you are bound to use, or if you don't, if you're not left with choices, then there is always a possibility of re-altering your mix design and still making the concrete economically viable and making it to perform to the required standards as set by the engineering design part of it. So don't be afraid to use finer sand. I would also request you to study table number 9 of IS 456, which is the indication towards nominal mixes. So nominal mixes has to be very carefully understood. A lot of people think 1, 1.5, 3 is M20, 124 is M15. No, please go through table number 9 once again. This is you will understand that you are wasting a lot of cement. So please be careful. I put this picture. Yes. just to 1 minute. Power varla. That's why I called you. A lot of people think one is natural sand, the other is fine sand, natural. Only one is M sand. No, all the four varieties I'm showing you is alternate sand only. Please be aware. Don't be fooled by the appearance of the sand alone. Please do proper testing and then try to adopt it. The alternates for river sand, there are many: M sand, dolomite rock sand, granite waste. The sawing waste from the granite industry is a very useful alternate, especially Bangalore, Hosur belt. You got access to these kind of waste. So these are the alternates which you can think about. Finally, I would like to end with this Tirukural. எப்பொருள் யார் யார் வாய் கேட்பினும் அப்பொருள் மெய்ப்பொருள் காண்பதறிவு. It is not that a person like me comes and gives you a very colorful presentation and asks you to use any alternate which is available. Of course, these are only indicators. I have only given you a cue. Please do follow the proper testing procedures as stipulated by IS 383 and then try to make the earth more greener by adopting to sustainable practices of concreting. Again, there is one more Tirukural which emphasizes that, which means முயற்சி திருவினையாக்கும் முயற்சியின்மை இன்மை புகுத்தி விடும். At least try. Your effort and your trial will make an impact rather than keeping idle. So I thank you all for this wonderful opportunity. I hope I have given a nice cue for you to start thinking on the path of alternate aggregates, and I hope everyone will follow suit in trying to experiment it at a small level and then try to adopt it in your sites at a full scale level. Thank you.
Thank you so much, Dr. Sudhakar. That was a very good presentation, very comprehensive presentation. In fact, as you rightly pointed out, many construction professionals has this, dilemma whether to use aggregates from other sources, especially the usage of M sand. You have clarified it very well.
Yes,
the difference between the crusher dust and all that this thing. In fact, how one needs to be very careful. In fact, as you rightly pointed out, it is a testing that we do at site. The caution in terms of especially grading and looking at the fine aggregates. And another important aspect which you covered was that SST condition. Many of the mixed designs they will not take adequate measures to change the water cement ratio based on the moisture content. I think
yes,
that all this plays a vital role. And although it's inert or sometimes inert, mostly it is inert, but sometimes you'll have to look at it. So a very good presentation. Thank you for sparing your time. Can we have some questions from the listening audience? Is it okay? Can I one question from Mr. Selvam? He is asking, can I use pond ash from thermal power station as fine aggregate without processing of it? Or process means what type of it should be used?
I have personally used pond ash, sir, in few of my projects. Processing it is very difficult. You can only do a mixed design alteration to it. You have to ensure that the pond ash is being collected from a non-polluted source, because if you actually look at the collection point of pond ash, it has got all rubbish inside. It is not that the thermal power plant will only segregate a yard for pond ash alone. They will dump whatever is not required into that same yard. So if your collection point is secure and you are satisfied that you are taking pond ash only, then I think it's a good alternative. Bottom ash is like pond ash is nothing but bottom ash in a slurry form. IS 383 also recognizes the use of bottom ash, so you can very well use it, sir.
So nicely answered. In fact, as rightly pointed out, IS 383 is a very comprehensive document which has been updated. And as rightly pointed out, before recommending the type of aggregate or replacement of aggregate, a lot of test is being done by National Council of Cement and Building Materials before IS recommends it. As you rightly pointed out, they do a very comprehensive testing to before recommending that how much percentage of it can be replaced and things like that. Because there's so many stakeholders who come for the meeting, and there is a lot of discussion, and everything is not accepted at its face value only after a lot of tests and all that. So you have rightly brought out that very important point. And I am sure that construction professionals should be able to use this code. And another very good advantage that we have got is that now BAS has opened their website also, wherein we can actually access the code in the digital form. And if you don't want to purchase it in the hard copy, at least you can go to the BAS website itself and you can at least view that, once you log in or you give your details. I think that is a very good important boon for the construction professionals. So it's very important that we update ourselves about various codal provisions. So a very good presentation. Thank you so much, Dr. Sudhakar, for that wonderful presentation. Thank you. And then again, this is the 65th webinar that we are having. In fact, we had webinars on various aspects of blending materials, cement, reinforcement detailing, which again is very important, which many of us neglect. Then we had on smart city, sustainable construction, and you were also pointing out on sustainability. We had a webinar by the BAS team actually on sustainability as per NBC 2016, the part 11 on sustainability, which they have been able to successfully integrate the various codal provisions and all that, and give a thrust on sustainability, which is very important today, because we need to ensure that the future generations also use the resources what we are enjoying. So that is a very good objective that we need to fulfill. So tomorrow at 11 a.m. again we meet for the 66th webinar, and the topic tomorrow at 11 a.m. would be significance on lean construction by Dr. R. Venkateshan, who is the professor at NICMAR. So he would be taking on lean construction tomorrow. So with those few words, let me thank all the professionals who have joined us for today's webinar. And thank you so much, Dr. Sudhakar. So we will again interact in future on various aspects. So the presentation was very good, a very good flow with lot of insights. Thank you so much. And I am sure that you would be making a lot of impact on the construction professionals through your presentation as well as through your practice. So, thank you.
If there are more questions, I see some questions.
Yeah, please. We can.
You can direct them to my email. I can answer them directly, sir.
Sure, sir.
Okay, sir.
Thank you again, sir.
Thank you, sir.
Nice day.